everybody, it is time for Kahoot. We got the code on the screen. It's sus. Some old memes there, Gage. Good to see you here, Gage. Good to see you here, Andrew Wynn. Good to see you here, Vish. Good to see you here, Courtney and Visa and Chris. Hannah, good to see you. Where's the on-campus review tonight? Can someone post that? I think Alyssa's holding a review and Moira might be holding a review. If someone posts it, I'll pin the message. I think they've sent out announcements, so check for those announcements. Thank you, Reese, right there. It's at Strong 201 at 6. So a little bit after this, let's replace the pinned message right here. Thank you so much right there, Bish, earning everyone some points. Tell everyone, go to Review 1 if you haven't. Review 1 is where all the review material is at, and you can check it out right there. We're going to pin that here in a moment. So we've got Review 1. Good to see you here, Parker. And there we go. Looks like we got all my students. Summit, good to see you. William, good to see you. I know if you're mods, you're my student. So that's how I know these are my students. We got Review 1 material right here. Make sure to check it out. There's a lot of review videos. Has anyone been watching those review videos? We're going to get started in 2 minutes. 2 minutes till Kahoot. Been watching those speedruns. Nice. All the review. The speedruns are fabulous. Thank you, Diamond, right there. So the biggest thing is take notes, practice. Mike, good to see you here. And then here's the big thing, though. It comes down to hearing the material multiple times. It's very hard to learn something the night it's due. So the Kahoot has some questions, which I've seen on the test. I definitely try to make this very much worth your time. But you want to come to class and then hear it again. Because to learn it one time, you have to, or to learn it, you have to hear it multiple times. You don't just hear something one. I mean, think about like learning things. It takes multiple attempts, like playing a song on the piano. If you're gonna learn a song on the piano, you're probably gonna play it like 50 times. So if someone said, "Oh, I can just learn this. I just have to hear it one time," I've heard people say that. Like, "I just need to hear something once. I've learned it." Well, you've maybe, you could repeat back what someone said, but we're not just going for memorization here. We're going for deeper knowledge. We've only got a few seconds left. How many people we got in the Kahoot? 94. We almost got 100. Let's throw out 100 points for those almost 100 people in the Kahoot. Join up now because we're starting here in 49 seconds. 49 seconds. Sup, Jackson, good to see you here. Caroline, good to see you here. Jerome, good to see you here. Kristen, good to see you here. Aksu, good to see you here. Hannah, good to see you here. William, good to see you here. Tell people we're Kahooting. You're going to review this later. And so ask questions while we play. I've got the WordPad open to do some review on. But the biggest thing is ask questions. Let us know what you're wondering. It's going to come down to review, and we got 25 seconds on the clock. But yeah, Flying Dolphin, good to see you. 94 people. We keep hovering about 100. About an hour-ish. About an hour-ish. Nice job, Megan, right there. That's a good way of doing it. Like, I'm going to be in the car. 10 seconds, so join up. I'm in the future, too, so join up quick. If you're like, oh, I'm going to wait till it starts. This is the moment right here. You got 5 seconds. Put it on the clock. You ready? 5, 4, 3, 2, 1, and the code will be in the corner for the remainder of the Kahoot. So that's got it. It is time to Kahoot. There's multiple choices, just like Canvas content. The exam looks like Canvas content. Best way to know what the exam looks like, your Canvas content. Let's do this. Here we go with the first question. Exam 1 review, part 1, new. First question is, which of the following phrases helps us identify a quantitative variable? So when you think quantitative, what does quantitative mean? Quantitative variables are what? How would you know something is a quantitative variable? Like if I say, are your eyes green, blue, brown, yellow, red? What color are your eyes? Would that be quantitative? Nah, it's kind of a group. What if I said like, okay, green are group 1? Well, that is not a quantity. So quantitative variables are actual real numbers, and you can always say like how much. It's weird to think this, but you could ask someone, how much is your age, or how many years do we have between us? But the idea of how much, they're similar. They're similar, real numbers. So real numbers, you want to think about how much, a quantity. So think of quantitative variables are a quantity. So sometimes we call the other ones qualitative, which are a quality, but I prefer to call them categorical. So which group would go towards categories? So really good work right there, 98. I usually do more review when there's more misses. Let's see who's in the lead right here. Yeah, Hannah, 100 points right there. Hannah says, if you can subtract them and make sense of the difference, they are quantitative. Thank you, Will, right there. So, Hannah, we're going to pin that message. That's a great way to know if something's quantitative. It has to be real numbers. And like Abish is pointing out right there with zip codes, even though they're numbers, they don't represent a quantity of how much zip code someone has. Because if you subtract them, you would be like, oh, my zip code's 1,000 more than yours. So that doesn't make sense for zip codes. They're not a quantity of zip code. A lot of quick answers. Joyful Urchin and Melodic Duck and Tropical Dog, Snowy Hamster and Mystery Llama in the lead. Here we go with next question. The University of Tennessee uses your student ID number. Maybe I shouldn't have said that. What kind of variable is this? It's a number. So that's a number. Now, there's a lot of things on the screen. We really only have two types. Sometimes zip code is, Shin right there, sometimes zip code is an identifier. But what about student ID would make it an identifier? What about student ID would make it an identifier? Like what key concept, if you're collecting data on students, like you go to different students and ask them their student ID, what key concept about this? It cannot repeat. So zip code can be an identifier in some data sets, but if you ask students their zip code, can a student's zip code repeat? Zip code can be an identifier in some data sets, like if you're identifying maybe zip codes or counties. I don't know if each county has a different zip code. There might be two counties with the same zip code. Kelsey, look at the Canvas content. That's what the exam looks like. So if it repeats, it is not an identifier. If it repeats, it is not an identifier. But your student ID number, if we collect it on students, cannot repeat for each student we collect on. Now, we have a few other things here. Continuous. What kind of variables are continuous? What kind of variables are continuous? Continuous are actually what kind of variables? Now, they can have decimals to them. So continuous are a specific kind of, so they're the ones that have decimals, and they're numbers, they're quantitative. The other name for things is discrete. So be taking some notes here while we talk about this. What kind of types of variables are there for categorical? For categorical, what kind of types of variables are there? Like quantitative can be discrete, which means whole numbers, like you ate 2 pizzas, or a 2.5 pizza would be a continuous amount of pizza. And Diamond points out there, nominal and ordinal. So nominal and ordinal, nominal means no order. Like if we ask, what state are you born in? Or ordinal would be like steak preference from rare to well done. It has an order to it going from like lowest temperature to highest temperature. So ordinal is categories that go in order. And Nick said it right there. Ordinal has order to it. Nominal has no order to it. And categorical variables are sometimes called qualitative for quality. So good review there of those concepts. Whoa, leaderboard mix-up. Snowy Hamster, good to see you up here. And Stellar Panda, Joyful Urchin in the lead. Next question, let's do this. Okay, if someone wanted to take bags of M&Ms as their samples and do a census on the bags, they'd be doing which of the following? So they're taking a whole bag, and maybe different bags, like they're taking different bags of M&Ms and doing a census on each bag. This is a very specific type of sampling method used right here. It's when you take the whole bag and do a census on it. You could take a classroom of students, do a census on different classrooms. You could take maybe a floor of a building and do a census of the floor. So this is very specifically a certain type of sampling. So write these down as I'm about to define them for you. Really good work right there. It is cluster sampling. So stratified right here is when you acknowledge a difference and then sample according to that difference. So if you were to stratify by different types of M&Ms, like peanut butter or chocolate, you would then sample randomly within the strata. Systematic sampling is when you take every kth element from a random starting point. So you could take every 5th M&M from a random starting point, and that's how you do a systematic sample. And simple random sample is when everything basically gets a number, and then you select random numbers, random observations. Clustering is basically a way to speed up sampling, where you would take like a whole bag and do a census. There's keywords in here, like the idea of a census is doing sample on every single thing in the bag. So very important right there, where stratified acknowledges differences. Make sure to check out the first lectures where we go over these. I think we did it towards the second week. We made sure to do a little special time where we went over each one of these, where you should know definitions for each one of these. Each one of these. This comes down to putting these on note cards and writing your own examples. You don't get a cheat sheet on the exam. Good question, Jerome, right there. No cheat sheet. What is the best way to learn all 4 of these concepts? What is the best way? What did I just say is the best way to know cluster, systematic, stratified, and simple random? What is the best way to know all 4 of these? I would suggest doing this right now. Note cards. Get a note card, put the definition for each of them, and then try to do an example, like try to make up your own example for each one and know the key aspects of each one. So basically, I can repeat the definitions to you 50 times. That clustering sample is basically a way to speed up, or we have clusters that are homogeneous. Basically, they're the same, like every bag is similar. And then we take the whole bag and do a census on the bag. So, or it could just be a classroom. Every classroom is considered similar. And then we take the whole classroom, do a census on the whole classroom. So write these down, check out the classes where we go over them. And the big thing is going to be your flashcards. Big help right there. And come to class, make some flashcards. We love it. Who's in the lead? We have Snowy Hamster in the lead right there. Stratified is when we acknowledge differences and then sample according to those differences. So in stratified sampling, you might acknowledge that some students are commuters and not commuters. And then you would sample like 40% commuters versus 60%. I think the exam shows it. It's like 40 to 60 questions. Check out the exam. I think it shows it right there. I think you can see like the exam says it is this many questions. If you can't take it yet, but it shows it. 51. Thank you, Sloan, right there. Sloan knows. How does a normal probability plot tell us if a distribution is normal? How does the normal probability plot tell us if a distribution is normal? Now, you see a normal probability plot, and the best way to read these is to read them backwards. A plot that tells us the probability a distribution is normal. So what way is this skewed? If we've already answered in the chat, what way is this distribution skewed right here? What way is this data here skewed? Anyone know? It is right skewed, right to the high, left to low, whatever way the Monster Man's tail goes. For those who don't know, in our class, we always draw the Monster Man here to make sure we know that we are talking right skewed. So let's see how, I didn't even see the answers yet on this. There's the Monster Man with the right skewed tail, right to the high, left to the low. We're talking high over here, the high side of the data, and that is a right skew over here, where the low is the left side. How did everyone do on that question? I didn't even look. Yeah, great job. So the line is the theoretical normal. This line right here, I'll zoom in on it. This line that goes just in a linear fashion. So is this normal or not normal? Yes or no? Here, we'll do a poll real quick. Is this, oh, that's a Q&A. Don't do the Q&A. Start a poll. Is this normal, yes or no? Monster Man, so good right there. Is that normal, yes or no? Does this suggest normality or non-normality? The answer is most definitely not normal. Way number one is look at the histogram. Way number two is look at this, and that is definitely not normal. Definitely doesn't follow the line. Now, what is the other thing called where when the p-value is below 0.05 for this, and I'm going to throw points here, just like the Canvas content, Jerome, just like the Canvas contents. Check out those to see how the test will look like. So the p-value does come into play a bit. When do we use the p-value right here, and what is that test called? Now, you have to know it's for this test, not just for correlation. Good answers. We do use it for correlation, but we learned it first with which concept? No one said it yet. We haven't done a t-test yet. We will do those later. Close Hannah, the goodness of fit test. A goodness of fit test. Here, I'll show one over here. So a goodness of fit test over here. Let's go ahead and clear this out. Like if we have data, I'm just going to call this, sure, we'll call it X for data. And we do random normal 100 data points. And then I make a histogram. Tell me, how does that histogram look? Do you see that histogram? We'll make it look even better. Let's do 1,000, then it'll look even cooler. It should look pretty what? Because I'm trying to make normal data. So there is the histogram. We look at it. Now here is the normal probability plot once I load up the function for myself. The normal probability plot shows us what we would expect for a theoretical normal, the red line, and our data points, which are close to the red line. So this is pretty normal right here. And then the goodness of fit test, Shapiro-Wilk. So Shapiro-Wilk, almost misspelled Shapiro-Wilk. It's called a Shapiro-Wilk test, goodness of fit test to see if the normal fits the curve. And, ooh, that one's kind of low, but not too low. So this is asking, is the normal a good fit for this data? The reason we call it a goodness of fit test is we literally take and do what to the curve? We literally take, why is it called a goodness of fit test? Think about why we call it a goodness of fit test. We literally take and do what to the curve? Why do we call it a goodness? We see if it fits it, right? We put the normal curve on and see if it fits it. And so on, and this is a keynote. This is a keynote right here. Check the lectures where we go in a little more detail. On a goodness of fit test, The high p-value indicates good or bad fit. What is the high p-value on a goodness of fit test? Not correlation anymore. Correlation's a different test. On a goodness of fit test, the high p-value would indicate what? Good or bad fit? Good fit. High p-value on a goodness of fit test indicates good fit. So the converse of this right here is when we have a distribution that's not normal, and you can see that's right skewed. Now the QQ plot, or the normal probability plot, is very not following the line, and the p-value, if you can't tell, that's a p-value about like that right there. It has 2 more zeros, but that is ridiculously tiny p-value. It's even smaller. So the p-value is very tiny, telling us that this is a bad fit. The normal probability plot tells us kind of also if it's a good or bad fit. This one's a bad fit with the p-value and the histogram. All three of these, histogram, normal probability plot, and p-value, indicate bad fit. And that's how we can check for normality right there. So definitely, if it follows the line, it's more normal. This one doesn't. It's also right skewed. And Hannah knows right there. The null hypothesis, Hannah, is actually normality for the goodness of fit test. So if you want to go by that, an excellent knowledge, Hannah, we're throwing you 50 points. If you have that sort of knowledge that you would reject the null, on the goodness of fit test, the null hypothesis is normality. So since the p-value is low for that last one we saw, you would reject the idea of normality and have evidence of non-normality. Excellent work, Hannah, right there. So with this, let's see who's in the lead. Snowy Hamster. Woo! Here we go. Royal Chicken. Which of the following graphics can be used for univariate categorical data? I'm going to put a cheat on the screen here in just a moment. Yes, so higher than 0.05 on the goodness of fit test. So Courtney, key thing right there. Not every time you look at a p-value, it doesn't mean good or bad fit. It's a higher than 0.05 on the goodness of fit test. Technically 0.05 or higher. So I'm going to put the cheat on the screen right here. Take a screenshot if you don't have it. You can pause the video later or come back to this. So there's the cheat answers right there. There's actually 2 answers on the screen. And what did Marshall Erickson tell us? Does anyone remember what Does anyone remember what Marshall Erickson told us about a few things on here? Like if you ask someone your favorite this or your favorite this. What did Marshall Erickson tell us? Very famous saying about this that we can use to memorize it. A bar chart of your favorite pies and a pie chart of your favorite bars. So if you ask someone your favorite pie, and great job, Bish, right there. If you ask someone your favorite pie, well, you're asking a categorical question. You could make a bar chart of it. No worries, Megan. Oh, yeah, univariate categorical, one categorical question. Bars or pies. When do we use histograms? When do we use histograms? When are histograms used? Histograms must be what? Histograms must be what? Histograms must be what? Quantitative. You can do bivariate stuff with histograms. There are bivariate histograms like side-by-side histograms, but a histogram by itself, look at the top left corner right there, a histogram or a box plot by themselves are just quantitative. This is a great graphic to have just as one of the things you know or look at, just going over what different things are made with which different kinds of data. Box plots are also univariate quantitative. So good graphic, good practice. Here we go with the next one. Leaderboard's going crazy. Don't worry if you're getting things wrong. You're in the right spot. So please hang out. People leave as the review goes on, but you're in the right spot if you miss something because you're here to learn. If everyone aced everything, then I wouldn't have made a good Kahoot. Which of the following is used for bivariate categorical data? Bivariate categorical. What does it mean if it's bivariate? And thank you everyone for answering questions while we're here. What does it mean if it's bivariate? Bivariate is the idea of what? 2 variables. Great job, Nick, right there. Bivariate is 2 variables. Categorical means we're asking questions like, what's your favorite pet? Or what state were you born in? Puts people into categories. No worries, Emma. Well, the truth is there's 2 answers on the screen. So mosaic plots and contingency tables. Now, when do we use scatter plots? When do we use scatter plots? Scatter plots are used when what? What is the condition for scatter plots? They are best friends. Great job, Mason, right there. Quantitative. The condition, and we do it with correlation, right? 2 quantitative variables for scatter plots. QQ, straight enough. And then what is a time plot? What the heck is a time plot? How would you define a time plot? Now, all time plots are scatter plots. Great job, Abish, right there. Notice how it lines up on quantitative? It's a scatter plot with time on the x-axis. Great answer right there, Mason. So it's a special case scatter plot where time is on the x-axis. It's still a scatter plot. We just call it a time plot because the x variable is in units of time right there. So that is what a time plot is. And excellent work, everyone. People have told me the Kahoots really helped. People have said my grade was better. You'll see some questions on the test that look either like it or maybe exactly like it. Here we go with the next question. Let's do it. The next question is, find the IQR for the distribution. I'll zoom in a little bit here. So find the IQR of that distribution. You should be able to identify it pretty quickly. If you know how to do the IQR, you know what the IQR is of that. Because you can tell. What is the IQR mathematically? What is the IQR mathematically? Oh, it might be Emma. Good answers. Like, what is mathematically the IQR? Q3 minus Q1, the 75th to 25th percentile, the distance they span. It's kind of like min minus max because it's just a distance, the range of the interquartile, the interquarters, which is 50%. What two values, can I zoom? I can't zoom any further. What two values are right here where I'm hovering over? Think about this is number of pets people own. What two values are right here? What two values are right there? The min and Q1, like the lowest amount of pet ownership was owning 0 pets, and 25% of people own 0 or less pets. Like a lot of people don't own pets. But then 50% of people, these are 201 students, own 1 or more pet or 1 or less pet. This diamond, which we don't usually put in box plots, is actually the mean, and it indicates right skew. Why is this indicating right skew right here? Great job, Nick. Yeah, that is true. Why is this indicating right skew? Like, how could you tell if you knew that this diamond is the mean? How could you then be like, yeah, it indicates some right skew? Well, there are outliers, but if this is the mean, the median, it's to the right of the median. The mean follows the skew. Does that make sense? So it is also right skew because Monster Man, and the mean follows the skew, and outliers often indicate skew on one side, but you can tell right here it's more pulled out on this side. Now, what is this point right here at 5? What is that point right there at 5? Great job, Kristen. The mean follows the skew. What is that point right there at 5? It's the max? That's the max? It is technically where the upper fence is at, but it might not be always where the upper fence is at. The outliers are the max. That is correct. This is the maximum right here. This point right here is the highest point that is not an outlier. Where are the fences? Now, the fence would technically be right at 5. It is true for this one. But this 0.5 right here is the highest point that is not an outlier. Q4 would actually be right over here at the 100th percentile. Like if you had 4 quarters, you have 100% of the data. So the whiskers go up to the highest point or down to the lowest points that are not outliers. And Jerome right there is putting the way to find mathematically where the fences would go. And if we plug in the data to Jerome's equation, I'll plug it. Thank you, Jerome, right there. Good answers. If we were to plug that in, we would get 5. It doesn't always work that way, that's where the upper fence is. It just happens to be for this data. So that is where the upper fence is at, and that is also the highest point that is not an outlier. So good work. Great answers, Jerome, right there. Snowy Hamster, Royal Chicken, Captain Gator. Great work. Here we go. The group of individuals or things we want to understand is the what? The group we want to understand. Very clear on this. The group we want to understand is the what? What do we collect to get an understanding? What do we collect to get an understanding? Well, we collect data. We collect data on a sample. So the sample is what we gather an understanding from. A lot of people say sample. We don't want to understand a sample. A sample gives us inferences into a population. So what do we call our study right here? Like when we learn things about a population, we learn it through the study of what statistics, because they give us inferences into population parameters. So we call, sometimes statistics is called what kind of statistics, because they infer things about populations. We call them inferential statistics, where we make inferences into populations. We use sample statistics to do that. Great job, Sarah, right there. So sample statistics give us inferences into population parameters. So if you're wondering what all these words are, imagine an election is about to happen. They would collect data taking a sample, and then the sample would give them a statistic on who they think is going to win. Maybe in the sample, 50% said they would vote for a candidate. So you'd say, well, I don't really know. When the election day happens, we'll get a population to come out and vote, and then the parameter would be maybe the candidate gets 52% of the vote. So the parameter is the truth for the population. Does S, population or sample in equations? Lowercase s is sample standard deviation. So lowercase s is sample standard deviation, and sigma is population standard deviation. 51, Ben, definitely check it out right there. So are we allowed to use a calculator? You are allowed to use a calculator. Any calculator, as long as it's not your phone or has internet capabilities. Just a normal calculator. TIs are allowed. Snowy Hamster, great job right there. We posted it. We'll post it here again, Amelia. Good questions. Here we go with the next question. Let's do it. Which variable is a special case categorical variable? Ooh, good question right here. Samples are what we take to understand populations. Like when someone goes out and takes a poll on people to see who they're going to vote for, that is their sample. So a sample is drawn from a population of interest to gain insight into the population. We should do pretty well on this one. Oh no! This is a key one from chapter 1. Discrete variables. Discrete are quantitative variables that are going to be whole numbers. Continuous are quantitative variables that have decimals. Now, nominal is a type of categorical variable, so a little tricky, but identifiers are way more special. So identifiers right here are categorical variables that only what? That cannot what? And we say it's a special kind of categorical variable. And it's really good to have it for a data set because it allows you to identify stuff. They cannot repeat. And Kristen has it right there, and Abish has it, and Reese has it. Identifiers cannot repeat. So if you're looking at data and if you want to know if something's an identifier, if it repeats, it's not an identifier. So key things right there. It is run through Proctorio. Run through Proctorio. Okay, let's see who's on the leaderboard. Fearless Stork, good to see you, and Dr. Yeti. That's a cool avatar right there. Oh, you guys got the same glasses. Here we go. Question number 10. Time plots are special case what? So this is a good review question right here. This is actually a bivariate time plot. It's got two different variables. So you got quantitative, and then we plot two series. Sometimes it's called a series. A little more advanced knowledge right there, but you need to know that time plots are special case whats. Now a dot plot, you might think it's a dot plot. Oh no, that might be the higher answer. Dot plots are like histograms. They just look like dots. So histograms and dot plots are quantitative. And once again, please take a screenshot of this. Oh, nice job. People said dot plot, but dot plots are just for what? Dot plots right there. Dot plots are just for what? Dot plots are for what kind of data? Dot plots are for what kind of data? Univariate quantitative, univariate quantitative. So a dot plot is for univariate quantitative data right there. And so it's for one quantitative variable, where time plots are special case scatter plots where time is on the x-axis. Dot plots right there from Luke. So make sure to know this. Mosaic plots are with contingency tables down here in the bottom right corner for bivariate categorical data. Okay. Fearless Stork, Wise Mouse, and Creative Ant sneaking up on Snowy Hamster and Royal Chicken right there. Here we go with the next question. Let's do this. Which distribution has the biggest range? Now be careful. Be very careful. Don't answer too quickly. You're going to have to look closely. Which one has the biggest range? Be careful. Be careful. Be careful. We usually extend the axes to a certain limits for certain reasons. What should people, when you look for the range, what should you always look for? When you look for the range, what should you always look for? When you look for range, what should you always look for? Outliers. Outliers. If you got this wrong, what do you think I want you to remember on the test? If you got this wrong, when you look for range, that dot was not there before Gage. I'm sorry. It was totally there, I promise. Why does on campus have the biggest range? Because of the outlier down here. So make sure to look for outliers. Take your time. But don't worry. Would you rather, if you're here in the Kahoot, what are you going to do when you look for range in box plots? If you're here in the Kahoot, what note are you reminding yourself? What are you reminding yourself of to do? What are you going to remind yourself of to do? When you take the exam and you look for range of box plots. Hey, Charlie, good to see you here. I swear it was dirt on my screen. You will look for outliers. So don't worry about getting it wrong. The point is, when you take the exam, you're like, okay, if I'm looking for range of box plots, I'm always going to look for an outlier to see, okay, oh, that one has a much bigger range. Sometimes it's pretty obvious. This question is like 8 seconds. Hit refresh on the stream or there's a live button. Hit refresh or hit live. You should be, there's usually like a 3 to 5 second latency, just the way YouTube does it. But pay attention to outliers. Sometimes you might miss them right there, and they control the range of the distribution because they can be the min or the max. If an outlier exists, it could greatly impact the range. Okay, next question. Let's do this. Here we go. What is the best measure of spread for this distribution? So when you look at spread, you can just see the picture going on right there. Spread is either going to be the IQR or the standard deviation. How do you pick between these two down here? What do we always evaluate first about a distribution? What do you always evaluate first about a distribution? Skew or not, the shape. And great job, Nick, right there saying the skew, since it's skewed, median and IQR. So median would be the proper measure of center, and IQR would be the proper measure of spread. So because the distribution is skewed, remember we go shape, center, spread, the center is the median, and the IQR is the spread. So the other two are paired over here. The mean and standard deviation are paired together for center, and spread for more normal data. The center would be median for this one. That is correct. And then the spread for it would be the IQR. Great job. Okay. Leaderboard's going crazy. Remember, don't worry if you come in first. 51 right there, Steven. Good question. Here we go. Next one. We made a chart of this too. Yeah, we did. True or false? Outliers can make a strong correlation weak. Outliers can make the slope of a line, negative line, positive. We won't worry so much about slope this time. But what can outliers do? What can outliers do to a correlation? They can also do this to regression. What can outliers do to correlation? A lot? Anything. Anything. So if you see this, I hate to teach to the test. Teaching to the test. It does matter here, Rock. Outliers can do anything. So what are you going to answer instantaneously about outliers? When it comes to correlation, now be careful. When it comes to correlation, what are you going to say about outliers? When it comes to correlation, and it says outliers can do this with correlation, what are you going to answer? True or false? Like outliers can make a correlation weak. Outliers can make a correlation strong. Outliers can make a correlation positive. Outliers can make a correlation statistically significant or something. Yes, true to all of that. But there are things outliers can't do. There are things outliers can't do. I'm dropping hints here. Good job, Snowy Hamster. How about this? Outliers can dramatically impact the IQR or the median. Outliers can dramatically impact the IQR or median. Superman's the outlier there. So think about some numbers. What is the median of these numbers? 1, 5, 10. What's the median of those numbers? 1, 5, 10. What's the median of those numbers? So put it in the chat if you want. The median of 1, 5, 10 is 5. How about 1, 5, 1,000? What's the median of it's 5, right? 1, 5, 1,000. 3 numbers. 1, 5, 1,000. Median's 5. How about 1, 5, a million? 1, 5, a billion. 1, 5, quadrillion. The median won't move. The mean does. Megan right there, perfect answer. The mean does. So the mean is impacted by outliers and the standard deviation is impacted by outliers. Hence, we don't use those when there's outliers. The proper measures would be the median and IQR. So that kind of gets into the theory right here that the median is not impacted by outliers, nor is the IQR impacted by the extreme values on the sides of the distribution. So really good review right there. Mean moves with the skew. Good answers. Hannah right there. Next question. Let's do this. Here we go. What is the Q3 for this data? So what are you looking for Q3? I'll zoom in so you can see it. You should be able to tell where Q3 is at. Where is Q3 in the data, and what does Q3 mean? Where is Q3? Like, what is Q3? If you've already answered, feel free to type in the chat. What does Q3 mean? It's the 75th percentile of data. Think of 3/4. So the 75th percentile of students are students who own 2 or more pets. 25% of students own 2 or more pets, and 75% own 2 or less pets. And great job. Easier question. So we'll go on to the next one here. Leaderboard is locked up. Let's find out who's going to win. Which of the following is not a condition for calculating a correlation coefficient? My class should know this very quickly. And we do have the next condition for regression. So I won't say what the next condition is. We have some values of correlation. 0.4 is just as strong as negative 0.4, just different direction. This is the weakest non-existent correlation, which is close to 0. So we know the 3 conditions for correlation pretty well. When you're doing correlation, you want 2 quantitative variables, QQ, straight enough relationship, MNOs right there, QQ straight enough, and no outliers. Plot doesn't thicken is the condition for regression. We'll talk more about that in chapter 7 when we talk about, no worries, Philip. No, you're doing great. Maybe you're on the leaderboard, I don't know. But plot doesn't thicken is a regression condition. So keep that in your mind. Here's the 4 conditions for regression. Are you ready? The 4 conditions for regression are QQ straight enough, no outliers, plot doesn't thicken. So why is it important to know the 3 conditions for correlation? Did everyone hear that? The 3 conditions for correlation are QQ straight enough, no outliers. The 4 for regression are QQ straight enough, no outliers, plot doesn't thicken. So why is it going to be nice? You just add one more condition, and then we teach you how to check it. So that's going to be on test 2. But once again, I love to show you things that are to come. And then if you learn these conditions, it'll help for the second exam too, which chapter 7 and 8 are over regression. Going on to the next question right here. Dr. Yeti, good to see you here, but Snowy Hamster in the lead. Here we go. $20 gift certificates to Amazon or Starbucks first, second, third. What percent track runners are expected to score a time higher than 290? I'll zoom in here so you can see it. That's a mean of 330 and a standard deviation of 20. 290 has a z-score of -2. 290 has a z-score of -2. 290 is right there at a z-score of -2. How did I know that? Well, this is 2 standard deviations below the curve, or below the mean. So we're asking higher than 290. I might actually start drawing this right here. The only information you need for this question is the z-score of -2. So we're going to go over here to a word pad right here and draw on it. So what numbers come to mind? I think it shows the answers still on your phone. What am I going to put right here? What's going to be between here and here? What's going to be between there and there? Now, ooh, good. Close a bish. 95. So now we know 5% outside divided by 2. So the answer is very clearly what? The answer is very clearly what? And this is the way some test questions could look. We'll tell you to use the empirical rule. The answer is very clearly what? 97.5, because you would add up the 95 and the 2.5 to get 97.5. How do we do? Pretty good, pretty good. Good practice. Try to draw these out on your own. So the more you can draw these out, the better you're doing. Love the empirical rule right there. Exactly. It's actually an E. It's actually an E with the empirical rule, but don't worry. It's not a spelling class. So, because I can't spell either. Still doesn't make sense, Derek. So when we do this right here, the 68, 95, 99.7 rule tells us that within 2 standard deviations is 95% of the data. So that's according to the rule, we know this. So the curve shows us that 2 standard deviations out is 95%. So if 95% of the data is inside of here, then 5% is remaining. We know that because 100 minus 95 is the remaining percent. So there's 5% over here and over here total. So how can we find out what one of these areas is worth? How can we find out one of those areas? So total, that's 5%. But how would we know one of those areas? To find one of those areas, we divide it by 2. So we take this 5% remaining, divide it by 2, and that means this is worth 2.5. Now, you know you've done it properly if everything adds up to 100% right there. But we want to see the area above here. Now, there's a quick trick to finding the area. We could just take 100% and do what to find this blue area over here? To find the blue area, we could just take 100 and do what? Because we've shaded the full curve right now, and Hannah has it right there. We could subtract and say, well, 2.5 is below here, 97.5 is above here. And this is going to take a lot of practice. Not a lot, but the more you get down, like, who finds these questions to be easy now? Like, maybe you're like, these questions are not that bad anymore. Like, I get one of these. I'd love it if you put some of these on the test. Show me empirical rule stuff on the test. I'll just be like, sure, I'll draw my curve, and then I'll draw the numbers. It just comes down to practice. So try doing the review questions on this. Try watching the videos. The more you practice this and write out the numbers, the better you will get. That's what we're here to do, is we're here to get better. So that's the practice. Okay, and let's see who's in the lead right here. It's the worst concept. We'll get you better at it. What percent of area is shaded on according to the empirical rule right here? Ooh, this is a good one. You can get this one pretty quickly, though. Can anyone put the math on this to get this super quick in the chat? So you can actually get this one really quickly. We'll see what anyone says. There's a really quick way to solve it. Might see a lot of... Yeah, Claire, that's a great way. Claire, great answer. And Jesse, that's what I was thinking. So we see a lot of different ways right there. 50% minus the 2.5, 95 divided by 2. You could also do 30. Yep, Brianna's got it right there. Brianna, great work. I was going to say 34 plus 13.5 if you know the areas between, if you've written it down. So as you see, we already have 3 ways to solve this. So any of these ways are great. People are taking the 95 between -2 and 2 and cutting that in half. Some people said above 0 is 50%. We just learned that above 2 is 2.5, so they're subtracting that. And some people can break down the full curve with the 34 and 13.5 here. It takes a little more practice to do that, but still you would get the right answer of 47.5. So really good practice right there. Review this lecture, review this speed run. It's going to be the best help at doing these sorts of questions. Okay, Wise Mouse, great work. Whew, who's going to win? Here we go. A Stats 1 test is normally distributed with a mean of 75, a standard deviation of 5. What percent of students make above a 70? What percent of students? What's the first thing you would do to 70 right here? Let's talk through this while people answer. So if you've already answered, let's talk through it. What's the first thing you would do to 70? I'll go to a word pad here at 20 seconds. You'd find the what? The z-score. So what is the z-score of 70? How many standard deviations below the mean is 70? It is a z-score. I think people are answering, yeah, it's -1. Yep. I said how many below the mean is it? So it is 1 below the mean, a z-score of -1. That is correct right there because it's below the mean, -1. So let's go over here to Word. And what we should be able to do is now we should be able to do our drawing. And we go right here. And we put 0 at the center. We go to -1 and 1. We do 68% between here. That leaves 16% on the outside above and 16% on the outside below, meaning above here is 84%. 84%. And I'll be back here in 1 minute. Stay tuned. Don't leave. Be right back. Okay, everyone's checking their points. Let's head back into the Kahoot. We are back. Let's do this. Okay, we're going to start here in like 5 seconds. Sorry for the delay right there. We are back. I said about 2-3 minutes. I think we did well right there. Here we go. Starting in 5, 4, 3, 2, 1. Next question. Quiz time. 68, 95. What comes next? 68. You can use scratch paper. That is correct. Credible. 68, 95. What comes next? 68, 95. These are the numbers you should know for the percent of area contained within each standard deviation, going out from 1 to 2 to 3. Make sure, well, you don't have to memorize them, but it's important to know. Maybe 25, 30%, Emma. Don't know for certain, but maybe. Similar to Canvas contents. 68. Oh, nice job. 68, 95. I'm so glad. Thank you so much. We still have about 100 people playing. Sorry, I left there. We have 99. I'll take it, though. Going on to that next question. Let's do it. I think we're into the speed run round, the bonus round. So be quick. This is the lightning round, I think, here with some big questions. And I've definitely seen 1 or 2 of these on the exam. Be careful. These are going to be some tricky question. There are multiple choice. There's no written on exam 1, I believe. There is on exam 2 or 3. We've already covered some of the interpretation in our class for exam 2. So check out last class where we give some hints towards exam 2. But here we go. These are tricky. Read them very carefully. We're going to probably have some mixing up of the leaderboard. So read these questions very carefully. Here we go. True or false, double the points. An ordinal quantitative variable that has been sorted in an ordinal number is a quantitative variable that has been sorted in ascending or descending order. An ordinal number is a quantitative variable. When you hear ordinal variables, what do you think? When you hear ordinal variables, what do you think? We covered this early on. When you hear ordinal variables, what do you think? You think order. What kind of variable do you think? Lillian put it right there. Emma put it right there. Look at what Sydney's putting, and Elizabeth is putting, and Hannah's putting. It's false. Because ordinal numbers are not a thing. We talk about categorical variables being ordinal. So ordinal is for categorical variables. They're categorical variables. Does that make sense? So people are pointing out right here, this is how people got tricked on this question. An ordinal kind of category is a categorical variable. Ordinal variables are categorical variables that it could be sorted. So ordinal variables are what? Ordinal variables, say it with me, are what? They're a special kind of what variable? Ordinal variables are a special kind of what? Not quantitative. Ordinal variables are a special kind of not quantitative. Categorical variables right there. Mubot's putting all his cats in the chat right there. What is the other type? Ordinal or what? Like ordinal means it has order, like steak preference from rare to well done. We also have what other things? Mubot's got all his cats. He's got it right, Vish? We also have nominal. We also have nominal right there, which means no order, like what state you were born in. So here we go with the next question. Let's check it out. And these are good. I've definitely seen some of these on the test. Snowy Hamster, great job on the lead right there. Next question. True or false? Double the points. Quantitative variables must be numeric. How am I trying to trick you on this one? Quantitative variables must be numeric. Well, we see a histogram right there, which is the display of a univariate quantitative variable. Can you think of a way to make a variable quantitative and it not be numeric? Well, quantitative variables stand for a quantity of something. So it's a quantity of something. So someone would need to tell you a what. If someone tells you a quantity of something, they would have to tell you a what. Super true, right? A number, right? Not trying to trick you. You're like, oh, he's trying to trick me again. A quantitative variable must be a number. It must account for how many there are. So it must be numbers. They're actual real numbers. And then in times, like you can have things that are numeric that are not quantitative. Like what state are you born in? And I say state 20 or something like that. So if we were to use numbers not quantitatively, or like what's your zip code, that's not a quantity, but all quantitative variables must be numeric. Not everything that's numbers is a quantitative variable though. So doesn't go the other way that all numbers are quantitative variables. So good stuff right there. Woo! Snowy Hamster in the lead. Fearless Stork. Let's see who's going to win this. True or false? Double the points. A variable that consists of numbers is always quantitative. I love the way I do this, because does anyone notice that if you listen in, what happens if you listen in? What happens if you listen into the previous one? variable that is a number is always a quantitative variable. Check out the previous question where we said, if it's quantitative, it must be a number. Yep, Claire got it right there. I give you clues. So there are things like what state are you born in, where we would say state 20, and that's not a quantity, or what's your zip code. So this is 100% false right here. Great job listening in. Oh no, Ben, a variable that it consists of numbers is always quantitative. Think of like zip code. So Ben, let's throw Ben 100 points right there. Don't worry, Ben, we're always going to overthink things, but try to come up with an example of something that would break this right here. I love numbers right there. ID numbers, yeah, ID numbers right there. Things like your student ID number is not a quantity of your student ID. So come, and thank you, Luke, for the positivity right there. We're here to cheer each other on, and if you get it wrong, just be like, okay, I need an example now, like zip code. So zip code is a number that does not represent a quantity of zip code. It's just a category of zip code. And rather get it wrong here than on the test. Lane, thank you for the positivity. Thank you, Nick, right there. We're near the end right here, and thank you, everybody. We're going to be reviewing more in class. Might do a night review. You never know. You never know. And please check out where can people go since we're at the end of the review right here. I'm going to pin this again, but here's the thing. I can go over all of this with you every single day, but it's going to come down to, if you go over here and go to the review and take the test, go through the review. We might do it. Yeah, we might. And then go through and watch some of the videos. I try to make them fun if you watch the speedrun videos. So we'll just do a preview right here.
Epic Stat Tool 1 speedruns of statistics. Brian Stevens versus Chapter 1. Stats start here. Begin.
We did add sampling to Chapter 1. We did add sampling to Chapter 1. 2 review sessions tonight, exactly. Shoe size, I'm not a fan of, because when it comes to shoe size, Lillian, we should just measure shoe size by like centimeters or something. Like, we should, the one with the mirror with cereal. Which one? Did I use a mirror? What did I do? Shoe size should just be numeric. It should just straight be numbers. So shoe size is a weird one. It's almost like category, because like 11 wide, like, or something like that is going to be not just a number. It's weird. Thank you, Maisie, right there. Oh, Maisie, for previous semester. So there is no formula sheet on this test. Other exams do have formula sheets, and I do think we have the reviews open for the other test. So if you want to see what other reviews look like, will be posted. But Terry's putting that the course material might change, so he's going to update these. So Terry's going to update those. I don't know. He might need to. So Terry's going to update these lists right here, but this is where they'll be posted for later. When I first watched the speedruns, I didn't know that it was an intro like that, and my computer was at full. Aw, Megan, that's awesome. You got some rabbits. We have our 2 rabbits, Morty and Jolly. So rabbits are great, especially when they flop. And then there's like, you're like, oh, a little rabbit. I'm still confused. Are zip codes are mostly categorical, could be used as identifiers. How would you know if a zip code was being used as a categorical variable or an identifier? Zip codes are not a quantity of zip code, though. So how would you know if a zip code was being used as categorical? We post animal pictures on the Discord a lot of times. How would you know if there's more than one? So if a zip code repeats, it cannot be an identifier. So there might be a way, if you're doing like polling districts that are in zip codes, like, or if you collect data on votes by zip code, the zip code could be an identifier. There are ways. But a lot of times zip code, like if you're talking to students, is going to be a categorical variable because it doesn't represent how much zip code someone has. It's just they belong to this group that has a number to it. Might as well call it zip code A, B, C. Like we could have made zip code C, B, B, A, B, A, B, B. I don't know. I'm just saying a bunch of random A, C, B. Like just B, 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 B. I don't know. Let's generate here. Wait, I'm going to do it. Ready? Generate a zip code. Here, we'll go here. Letters. I just have to do this now. Letters 1 through 3. There we go. And then we're going to sample from letters 1 through 3. Here's your new zip code, 8. And what am I thinking of? Oh, no. Why can't I think? It's going to say, there it is. Replace equals true. Okay, your new zip code is B, 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 A, B, C. There you go. That's your new zip code today. B, 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 A, B, C. It's weird. We got a bunch of B's right there. But that could have been your zip code. You never know. Is that good or bad right there? So true or false? Here we go with the last 2 questions. A bar chart is a good way to visualize identifiers. A bar chart is a good way to visualize identifiers. Oh, Jelly Bingus and Jelly Bongus. Megan, that's awesome. I see some posts on the Discord already. When you think about identifiers, what is the only point of identifiers? Thank you there, Will. It's one of my favorite shirts. Big Doug's pretty awesome. Old school video games right there. When you think about identifiers, identifiers are only used to do what? Identifiers are only used to do what? It is false because identifiers are only used to identify. When do we make bar charts? Bar charts are made for what? They might say, but it's a special case this, but we don't really graph them. Identify. If you were to make a bar chart of an identifier, here's what it would look like. Like, let's say we have a whole bunch of letters right here. I'm going to turn this into variable. This is what it would look. It would be so non-informative. So, factory. So, bar plot of variables. This is our table plot. This is what it would look like. Really? What am I doing wrong these days? Oh, table. Been a long day. Unexpected. There we go. Put that there. There we go. Does this look informative to you? And why does it look this way? Does this look informative? This is a bar chart of an identifier. Why does it look this way? It doesn't look informative, right? So why does it look this way? Because if it's an identifier, there's one occurrence for each one. There's really nothing to graph. So each observation here only occurs one time. So if you were to look at the table of this, they all occur only once. We're pretending that A, B, C, D, E are identifiers, like I had 26 students and I gave them each a letter. So it wouldn't really inform you of anything. So we do not think of bar charts as a good way to do identifiers. You don't usually graph identifiers. They're just to identify. They'll be $2.99. Well, we got here. Remember, first, second, third, get $20 either Starbucks or Amazon. So please email me, bstevens@utk.edu, and be like, hey, Brian, email me from your UTK account. That way I know it's you. And say, hey, Brian, here's the email address I want it sent to. Choose Starbucks or Amazon. And make sure to email me if you're in first, second, or third. Go Snowy Hamster right there. Snowy Hamster's in the lead. We got Wise Mouse, Fast Leopard, Royal Chicken, Fearless Stork, Snowy Hamster. Who's going to win? Let's find out with the last question. True or false? Double the points. And great job, everyone. Thank you so much right there for the positivity. There's sometimes a good reason to remove outliers. Wow, we got some fast answers right there. What is the number one reason to remove outliers? What is the number one reason to remove outliers? We've asked people, how many days a week do you drink? And they say 10. And we're like, what? Well, thank you, Abish. I know, right, Anna? Because there are sometimes good reasons to remove outliers. We remove outliers when they're just not true. You don't remove them because you don't like them. If someone lies or they get totally mixed up, it can't be true or something like that, that's a super good reason to remove it. Like if someone's like, what's your salary? And they say negative 500. And you're like, well, you can't have negative money. I mean, what are you trying to tell me? How much money you lost? So when the answer just can't be true, that's like the number one reason when the data is false. So you wouldn't keep it in because you don't, or you wouldn't remove it because you don't like it. You remove outliers when it's like, this is a theoretically impossible value. Sometimes you can write your survey in a way that people can't answer those questions. That's a good way to eliminate a lot of those possibilities. But you could also have theoretical combinations that exist. Like, once again, we always support everyone here. We have a saying, you do mu. But I want you to look at this data, and this one was a scatter plot right here. Similar ask. I want you to look at some data right here to end off. And I want you to tell me, what do you see about this individual over here? We're going to plot this so you can see them. And let's go to, what do you know about this person right here? Tell me about this person. And then we're going to do the leaderboard here. Tell me about this person. Tell me 2 things about that person. They're quite the outlier. Tell me 2 things. Tell me 2 things. We have a saying here, you do mu. We're happy to, whoever you are, you doing you, that's excellent as long as you're living a good life, living your best life. But well, how tall and how small? How tall and how small? So we can actually find them in the data set. So how tall and how small? We can go and find them right there. So this person is 6'3" and weighs 75 pounds. They want to weigh 250. But 75 pounds is very tiny. 6'3" is very tall. Not very tall. So, Cassie, that might be it, right? They might have forgot a 1, or they might have double input their height for their weight, right? They might have said, well, I'm 75 inches tall, and then they thought they might have just repeated the number, forgetting to change it. This is real data, and that person right there is very, very odd. So maybe they made a mistake on the units. Maybe they entered a value twice. But either which way, we might have to eliminate this value right here and be like, I don't know if we can use this because I don't think they're 6'3" and 75 pounds. It's reaching towards the theoretically impossible values. Like, you can't be 6'3" and be 10 pounds. That's a theoretical impossibility. So is this a scenario where we would ignore? Probably ignore them, right? Yeah, so Emma right here. This is a judgment call one where I'd probably say, like, we should ignore them. Now, if you look over here at other data points, could you ignore, like, you go to, where's my plot? You go to just another random point. You say, like, okay, this person weighs a lot less than we would expect. They're like 6 feet tall, and they maybe weigh 120. Well, my brother and I were 6'3" in high school, and we weighed 150. So, but we were pretty skinny back then. So there's a lot of theoretical possibilities. Like, my brother and I would be over here, and we were really skinny running cross country. They weigh 75 pounds less than us. It comes down to the call of the researcher. Yeah, well, that's probably true. You can use the grade calculator to check it out. So you need a good reason to remove outliers. Does that make sense? You don't just look at an outlier and say, I don't like that point. No one removes outliers by saying I don't like points. But let's do the leaderboard. I don't know why we didn't do it right away. I just wanted to talk a little bit about outliers. It's time for everyone's favorite leaderboard person.
Tiny. Wait, that's not my voice.
Tiny Brian. Here we go. Let's do the leaderboard. Okay, in third place, Royal Chicken as a cheeseburger with a monocle. That's cool. Fearless Stork. That looks like a stork. And in first place, what's up, Will? We got Snowy Hamster skiing downhill right there with their goggles on. Great job. When we remove outliers, do we need to document why we remove something? You bet. Wait, Brian, you remove me.
We just removed Tiny Brian right there. Make sure to email me if you were in first, second, or third, so I can send you either Starbucks or Amazon, your choice. Tell me which email to do it. Send it to me from your UTK email. And great job on the review, everyone. Please check out the review videos. Check out the review tests. They're going to really help you learn the material, because as much as I can say the things multiple times, it's going to come down to your practice. And let us know if these Kahoots help you, because a lot of people have told me the Kahoots have been a good way to do it, to practice for the exam. Is the exam? Nope, not all multiple choice. Check out the Canvas content. #1 way to know what the exam looks like, because the Canvas content is made to look like the exam. So there's some multiple choice, some numeric entry. This exam does not have short answer, though. Well, thank you, Emma, so much. Yeah. So a lot of people tell me after the first test, they're like, yeah, it helped. It's 18 flat, Lillian. Well, that's awesome right there, Lillian. Well, with this, here, wait, we didn't do the right outro. Let's do an opening. I should have done this opening. Okay, everyone, you ready? Until next time, bye for now. I'm going to the wrong openings. Where's my right opening? Okay, that's the opening I want. Okay, it says it's on the opening. It's got 201.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No! Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So we'll see what happens.
Bye for now, everyone. Woo! I'm back.